Hello students, welcome back to my channel. So let us continue learning the database concepts. In today's session, we will be learning about entity relationship diagram. So from now onwards, we will be continuing all the components which are related to the entity relationship diagram. So today we will see the main three components. So before we move on, let us first learn what is an entity relationship diagram. So an ER diagram is a visual representation of the data that describes how data is related to each other. Now we know that a database is a collection of data, and we have also seen that in relational database scheme, like if we are following a relational database scheme, then we are going to store the data in the form of tables and columns. Now the entity relationship diagram tells us that how data are related to each other. All the data which we are storing inside the database, how they are related to each other. So I have shown an example here. This is how usually an ER diagram looks like. So in today's session, we will be learning the different notations about this, like what is the meaning of this rectangle, what is the meaning of this oval shape, what is the meaning of this diamond shape, and what these line indicate. So what exactly is the relation between them? So I'm going to keep this diagram as an example, and we will discuss the entity relationship diagram, right? So we know now what is an ER diagram, the definition we know. Let us see what are the components of an ER diagram. So basically there are three components, mainly entity, attribute and relationship. So in today's session we will be looking into each one of them individually. Under each, for example, under attribute there are different types, under relationship there are different types. So I'm going to be covering all of them in today's session. So today's video might be lengthy, but I want to cover them in one video so that there is no confusion. That is the reason, right? So first let us start with the first component of an ER diagram, that is your entity. So what does an entity means? So an entity can be any object, place, person or a class. Okay, so in the ER diagram, entity is represented using rectangles, something like this. So we have seen this in the previous diagram, isn't it? So what is the meaning of that? So as of now you understand, student is an entity in a database. So what all student can have? Student can have a register number, he can have an address, he can have a name, he can have a pin code, all those components he will have. But a student himself is called as an entity, right? So consider an example of an organization, an employee, a manager, department, product, and many more can be taken as entities from an organization. So if you're considering an organization's database, then the entities will be employee, manager, department, product, etc. Okay, so if you are representing in the form of a table, how it will be? Then I can have an employee table, I can have a manager table, I can have a department table. So what you can say is, if we are comparing an ER diagram with the relational database model, then I can say that an entity is nothing but a table. Okay, just a comparison for you to understand. So an entity can be any object, place, person or a class. Okay, so this is what a definition of an entity is. So if you have to see our previous diagram, what are the entities here? I have basically two entities in this, which is student as well as college. So remember, they are represented using a rectangle in an ER diagram. Now let us move on to the next component of the ER diagram. So before that, in entity itself there are one more type, which is another type is called as weak entity. So we know that a simple rectangle represents an entity. So what if there is a double rectangle? Then we will call this as a weak entity. Why it is weak entity? What is the meaning of that? So it is an entity that depends on another entity. Weak entity doesn't have any key attribute of their own. Now what is this attribute? Attribute we will learn in the next, that is the next topic itself is attribute. But before that, try and understand, loan is an entity. Okay, so what all loan, if at all I'm considering it as a table, then what all loan will have? Loan will have interest rate, isn't it? Then it will have a principal amount, then it will have a time, all those detail, and who borrower name, whoever is borrowing, all those things a loan will have. What about payment? The monthly payment, what I need to do, it will not have any other attribute. It is just the amount, isn't it? Payment is nothing but an amount, so it doesn't have any other component attached. But from where will I get to know what is the amount I need to pay? I will get to know from the loan entity. Okay, so loan entity will have all the details which is required for me in order to calculate the payment. So payment here is an entity which is totally depending on the loan, and payment doesn't have any attributes. Okay, so that is why it is an weak entity. So remember, a weak entity always depends on another entity for all the details. It will not have its own attribute. So what is this attribute now? That is our next topic. So an attribute is nothing but it describes the property or characteristics of an entity. Now that we know what is an entity, that property of that entity or the characteristic of the entity is nothing but attribute. Okay, so for example, see here, name, age, address, etc. So I have a student entity, and name of that student becomes one attribute, birth date becomes another attribute, roll number becomes another attribute. So these oval or eclipse shaped representation is nothing but attributes. Okay, so that is what the attribute means. So if I'm looking at our previous diagram, then which are the attributes? So we discussed that student and college are the entities. Then student ID is an attribute, student name is an attribute, student address is an attribute, college ID is an attribute, and college name. So these are the attributes. The student entity has 3 attributes and college has 2 attributes. So if at all I'm comparing this with the relational model, then I can say that student is a table and attributes are the name of the columns, isn't it? So this is what an attribute means. Attributes represent the properties of an entity. Now we will see the different types. Okay, so the very first one is a key attribute. What is this key attribute? Key attribute represents the main characteristics of an entity. That is, it will uniquely identify the content of an entity. It is used to represent primary key. So key attribute is nothing but represent the primary key. If I'm comparing it with a relational table, then whatever the primary key column is there, that is nothing but my key attribute. So I have eclipse with an underlying line represent the key attribute. So can you tell me, in this situation, I have student, which is my entity. I have 4 attributes, but as you can see, ID, which has an underline, this represents my key attribute. So though name, ID, address, and age are the attributes of student, ID represents the key attribute. And how do I represent it? Using an underline. So this ID is nothing but it represents, in a relational database model, it represents the primary key of this particular table. Okay, so that is what our key attribute is. What is a composite attribute? Next type of an attribute is composite attribute. An attribute can also have their own attributes. These attribute is also known as composite attribute. That is nothing but, for example, I have a student entity and student has address as an attribute. Now this particular address can have further sub attributes. Now address is called as a composite attribute because it is further divided into city, state, and zip. Okay, so such attributes are also possible in to be there in an ER diagram, and they are called as composite attributes, right? Next we have relationship. Okay, so this is the third component of an ER diagram. First one we have seen entity, second we have seen attribute, now third one is relationship. Okay, so what is this relationship? A relationship describes a relation between entities. So how they are related to each other, how two tables are related to each other in a given database is nothing but a relationship. Okay, so there are 3 types of relationship: binary relationship, recursive relationship, and ternary relationship. So as you can see in this diagram, so I'll have first entity and the second entity, and there will be a diamond shaped diagram, which is nothing but a relationship. It shows the relationship. Even we are going to learn about these numbers. These are nothing but the cardinality that we will be looking in the next session. As of now, we will only be learning about the relationship. So there is an example here. If I have a teacher entity and a student entity, for example, if this is a university database, then I'll have a teacher entity and student entity, and there is a relationship between those, that teacher and student, that is teacher teaches student. So teachers is a relationship between teacher and student, right? So now let us see these different types of relationship. First, let us see what is a binary relationship means. So binary relationship means relation between two entities. Okay, this is further divided into three types. So in a binary relationship, we will have only two entities. So it is possible to have more than two entities in any relationship, but in binary, remember, we will have only two entities. So further, binary is divided into one to one, one to many, and many to many. So first, let us see one to one. This type of relationship is rarely seen in real world. Why? Because here one entity participates, only one entity participates in a relationship into the another entity. For example, one students enroll to one course. Okay, but usually in real world, what would have happened? Student would have enrolled for more than one course. Okay, that is also possible. But when I say it is in one to one, which means that one student is enrolling for only one course. Similarly, one course can have only one student. That is the reason we say that it is not, it is rarely seen in a real world, because a student may be enrolling for one course, but it is not possible that a course will have one student. That is very rarely possible. But basically you should understand that one to one relationship is nothing but there is a one relationship from this side, similarly there is one relationship from this side. So a relationship will have one and one here, because entity will be participating both of them, only one participation will be there from both the sides. That is nothing but your one to one relation. Next one is one to many. Now, what is this one to many? It reflects business rule that one entity is associated with many number of same entity. Okay, so as you can see here, there is one entity. It is participating in the relationship into many entities. Similarly, many entity is participating by one. So see the example here. For example, student enrolls for only one course, but a course can have many students. So student can enroll for only one course. From him, the participation is one, but a course can have many students. That is what the meaning here one to many means. Okay, the arrow in the diagram describes that one student can enroll for one course only. So from this side there is only one participation, but there is from this side there are n participation. This is called as one to many relationship. Next we have many to many. Now what is this many to many? Many to many simply means that the many students can enroll to more than one courses. Okay, so there are n participation from this side. Similarly, there are n participation from this side. Okay, this should be n. So n students can enroll for n courses, and n courses can have n number of students. That is what the meaning of many to many is. So these are the three binary relationships, that is one to one to many, and many to many. I hope this is clear. So after binary relationship, we have something called as a recursive relationship. Now what is this recursive relationship? So just like we had binary, recursive is nothing but when an entity is related with itself is known as a recursive relationship. Now when we are learning about C programming, we have learned about recursive functions, isn't it? A function calling itself is called as recursive function. Similarly, a recursive relationship. So here we have an entity called as employee, and employee is reporting to employee himself. Okay, now how is this possible? Now when I say an employee here, the regular employee also as well as manager, both are coming under the employee entity itself, isn't it? So a regular employee as well as manager come under employee, but this employee will be reporting to the manager, which is nothing but the employee is reporting to the employee entity itself. That is why we will call it as a recursive. So a entity is related to itself. So there is a relationship, but there is only one entity which is participating. It is called as a recursive relationship. Okay, so this is the second type of a relationship. And the third and the last type of a relationship is ternary relationship. What is this ternary relationship? A ternary relationship, an association among three entities. Like we said in binary, we said that there can only be two entities. Now ternary is three among three entities. So this type of a relationship is required when binary relationships are not sufficient. Okay, so in every relationship, it is not possible to have only two or one when it comes to recursive. There may be need when we want three entities to be participating in a relationship. In such cases, it is called as a ternary relationship. Okay, so when binary cannot accurately describe the semantics of the association. For example, there is a relation here where teacher is taking a course. He is in charge of a certain course which is taken by certain class. Okay, so in this situation, when you want to represent a ER diagram where all three entities must be participating in a relationship, then I will call that particular relationship as a ternary relationship, because we should be able to show the relationship between the data, exactly how it is in our real world, and that can be done using a ternary relationship. Okay, students. So in today's session, we have seen what is an ER diagram means, what are the components. So under components, we have seen entity, we have seen attribute, and we have seen relationship. Plus, we have seen the different kinds of attributes with different kinds of relationships. So I hope today's session is helpful. Do let me know in the comments which other subjects you want me to take up next. So in the coming sessions, we'll be continuing this ER diagram and we will learn about the cardinality and constraints and everything. So till then, keep watching, students, keep learning.